All right, so second part of inductive reasoning, I want to talk about this multiplication rule that Gensler talks about, and also this idea of independence, which is honestly, if anything, more important than this idea of being mutually exclusive. I mean, they're both really important, but for reasons I'll get into, this one is super important because some mistakes that people make about inductive reasoning really come back to this idea of independence. All right, so let's talk about, you know, how you figure out if two things happen together, if A happens and B happens as well, right? When A and B are independent, then the odds of A and B to is pretty simple, right? Take the odds that A happens times the odds that B happens. That's how likely the two are to happen together. So, very simple example, flip heads on a coin twice in a row, right? Well, look, there's always some student who like delights in pointing out to me that most coins aren't fair, and that as a matter of fact, I think even in quarters, like they found, like, well, I think heads comes up something like 50.2% of the time, and tails is 49.8 or something like that, right? I'm sitting here, you can't see me, I'm kind of rolling my eyes. Okay, be that as it may, though, roughly one half, right? Roughly one half, we'll just treat it as one half, right? Heads on first flip, one half. Heads on second flip, one half. And look, what you come up with on flip one has no bearing on what happens on flip two, right? These two are independent. Independent means A and B don't have any effect on each other being true. One half, one half, odds of flipping heads two times in a row, 1/4 or 1/4. Because you just multiply one half and one half. Punch this in the calculator. If you want 0.5 times 0.5, you'll get 0.25, which is also just a quarter, right? So, A and B being independent means A being true or false has no effect on B being true or false. No effect on the odds. I mean, one way to think about this is if A and B are independent, me telling you that A is true or false tells you nothing about how likely B is. Nothing you find out about A moves the odds that B is true or false, right? Coin flip 1, coin flip 2, independent events. Getting heads on coin flip 1 tells you nothing about how likely heads is to come up on coin flip 2. Dice roll. I say dice roll. I should say die roll. No, sorry, it is dice roll. I think about 2, right? Imagine I roll 2 dice together. I get a 7. That's really the most likely number you're going to get. I roll it again. I think the odds of 7 are like 1 in 36. Well, it's a random event, especially if you're throwing in a casino and it hits one of those little barriers that like bounces it off. What I roll on this dice roll has no impact on what I roll on the next one, right? 7 is just as likely or unlikely as it ever was on roll 2, regardless of what I come up with on roll 1, right? Sorry, like I said, we're going to do a lot of talk about gambling, right? Or you could think about this, right? It is whether or not it's raining in Tübingen, Germany. If I look at the weather and it's raining in Tübingen, well, that tells me nothing about what the country music station in Galax, Virginia is going to play next, right? As far as I know, right? Maybe the DJ has some weird policy whenever it's raining in this city in Germany, he plays Merle Haggard. I don't think so. Most likely, weather in Germany has no impact on what the DJ at this country music station is playing, right? A more counterintuitive one draw a heart, draw a face card, right? Think about it this way, right? What are my odds of drawing a face card? Well, there are 12 face cards out of 52. We reduce that down, we do the math, and it basically comes down to 3 out of 13. All right. If I tell you I drew a heart, well, there's 3 face cards that are hearts. King, queen, jack. 3 out of 13. I have told you nothing useful. You don't adjust the odds that it's a face card at all. 3 out of 13 before, 3 out of 13 after I tell you it's a heart. It has no bearing on this. I can't resist saying I had a student last semester who had a knockdown drag-out argument with me about the ace being a face card. He got very mad at this question. He's like, 4 out of 13, 4 out of 13, there's an ace. Again, I'm rolling my eyes. All I can say is, if you think the ace looks like a face, you have some very weird idea of what a human face looks like, right? It does not have a face on it. You know, if it's just a giant club or a heart, that is not a face. 3 out of 13, ace is not a face card, despite how angry this guy got about it. Anyways, independent events. One way of thinking about it is, if I tell you A is true or false, tells you nothing about B, right? You know, if I tell you that it's a heart, you don't adjust your odds of it being a face card at all. 3 out of 13 before, still out of 3 out of 13. Here's some events that are not independent. And events that are not independent are much, much, much more common than independent events. You can't just call these dependent, but all we're getting at is not independent. Make an A on test 1, make an A on test 2, right? If a random student in a class tells you that she made an A on the first test, whatever you think the odds are that she'll make an A on the second test have went up. Making an A on the first test doesn't necessarily mean you'll make an A on the second, but if you tell me you made an A on the first, I'm going to peg the odds that you make an A on the second higher than I did when I just knew you were a random student, right? Draw a red card, draw a heart, right? If I draw a random card, what are the and I don't tell you what it is, what are the chances I have a heart? 1 in 4, right? If I tell you, well, it's a red card, but I'm not going to tell you if it's a heart or a diamond, well, you have to adjust the chances. Random card 1 in 4, once you know it's red, the odds that it's a heart have went up to 1/2. I have a good friend who lives in Tübingen, which is why I just picked this random city in Germany. If it is raining in Tübingen, my friend Alan, he lives there. What are the odds he takes an umbrella with him out of the house that day? Maybe he doesn't. That would be bad. But the odds that he takes an umbrella with him go way up if we know it's raining in Tübingen, right? These are dependent events. It's St. Patrick's Day. Randomly chosen student wears green to class. The odds that a randomly chosen student will wear green go up when it's St. Patrick's Day. Current song on random radio station is Taylor Swift. If I just am messing with the radio and a random station is playing Taylor Swift, what are the odds the next song will be by Merle Haggard? Almost 0, right? It is very unlikely that a station that plays current pop hits is gonna play old country music, right? Might happen, but if I hear Taylor Swift come on the radio, the odds Merle Haggard's gonna be the next song way, 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 way down. All right, so that's to talk about independent and dependent events. And remember, Gensler tells us when A and B are independent, the odds of A and B You can figure it out by taking the odds that A times the odds that B. Well, keep that in mind. Ask yourself what's wrong here. Suppose my wife, this is not going to happen. It's too early for hurricanes. But, my wife during hurricane season kind of obsessively follows little spaghetti trackers. You can see them. And imagine we see on the news that there's this hurricane and we don't know quite what way it's going to go. Maybe it plows into South Carolina, but also some of the tracks have it going north and hitting us. You say, well, it's got about a 1/2 chance of hitting Hampton Roads, right? Well, what are the odds that it floods on Ghent in any random day? I don't know. Let's just say 1 in 10, right? If you don't come to Norfolk much, Ghent is a low-lying part of Norfolk, pretty prone to flooding, right? I know this because the daycare my kids used to be in is in Ghent. And so there were one of the few days it's like, it's flooding, come get your kids. I'm like, oh no. Anyway, so let's say that 1/2 odds that the hurricane, the tropical storm comes through on Monday, and odds that it floods on Ghent any given day are 1 in 10. So what are the odds that this tropical storm hits and it floods in Ghent? 1/2 times 1 out of 10, 1 out of 20. Well, look, if you think about it for a second, you know this has to be wrong, right? If this is a part of Norfolk that's prone to flooding and a tropical storm hits that drops 5 inches of rain, a whole lot of rain, the odds that it floods in Ghent are pretty much 100%, right? 1 out of 20, that's crazy. That is wrong, right? The right answer should be, well, 1/2, right? If the storm hits, it's going to flood. Well, look, what's went wrong here is A and B are not independent. Whether a tropical storm hits has a huge impact on whether or not it floods in Ghent. So you have to use a more complicated formula. When A and B are not independent, you have to use this formula, odds that A times odds that B happens when A does. So in my example, odds that tropical storm hits, 1/2. Odds it floods in Ghent when tropical storms hit, or if a tropical storm hits, pretty much certain, 1 out of 1, right? 1/2 times 1 out of 1 equals 1/2. That is a plausible answer. So, we can see the formula is pretty good. To use it for a more realistic example, odds that you draw an ace on the first draw and king on the second, 1 out of 13, because 4 out of 52 are aces, 1 out of 13. Well, if you draw an ace, there are 4 kings left and 51 cards, so now you multiply by that. 4 out of 663, 0.07%. So, very important if you're going to use this formula that you keep in mind whether the things are independent or not. Independent, you can use the simple formula for A and B happening together, multiply one by the other. If it is not independent, you have to use this more complicated formula. Chance that one happens times the chance that the other thing happens when the first thing happens.